Okay, CICS. By the time we're done, describe CICS processing, describe the application program interface, list 6 programming languages used to write CICS applications. You should be able to list 2 CICS programming techniques and describe the CICS system definition. I should say definitions. List 3 types of CICS supplied transactions. You'll understand what we're talking about here by the time we're done. As I mentioned earlier, inside the zIOS environment, you've got a batch environment, submit JCL to background, and then the other type of environment is your OLTP environment, online real-time transactions where you do queries. There's usually a small amount of data involved to get a reply back from a query. And then when you do a query, an application program's involved to actually get to the data source to return back a reply. So to be real simple about a transaction environment, so you've got an operating system, and then within an operating system you can have a transactional system. Then the transactional system can run application programs. So the end user is communicating through the operating system to get to the transactional system to talk to the application. Then the application uses the transactional system to communicate through the operating system services to get to a data source. That's what this is representing at a very high level. CICS stands for Customer Information Control System. And I will tell you that, and Bruce may be able to confirm this, there are probably more CICS transactions in a day than are internet pages served in the internet. And there's people that process billions and billions of transactions, sometimes a day.
Yes.
CICS is probably, with little debate, the best transaction processor in the world. It's very fast, very efficient, well architected. So what a transaction processor does for you, it runs online applications, many sessions using the same application concurrently. It manages the sharing of resources like the data, the pool of terminals. It maintains integrity of data. There's prioritization of execution with fast response. So this is a very high-level architecture, and the CICS is broken up into a lot of different functions. And as you can see here, this is just a very small fraction of the functions. I believe in the presentation I actually list all of them, but you have an application programming function, web services, database services, external interfaces. There's all kinds of things that make up the CICS architecture, and I won't name them all off. Here's actually a list that comes straight out of the book, and I want you to know that CICS, the 3-character identifier for CICS is DFH. So CICS modules, they'll begin with DFH. CICS messages will begin with DFH. But CICS, notice it took the 4th and 5th position for additional characters in the message ID. Well, that 4th and 5th position is the subcomponent. So not only do you know when CICS gives you a message, you know what subcomponent gave you the message. For example, if it was EJ, enterprise Java domains involved. If it was, let's pick another one. Let's say it's CR. this thing called this is inter-system communication remote scheduler component, where two CICSs can be talking to each other. They could be in totally different companies. That happens a lot. If I do let me give you an example. I do a credit card transaction in a department store. And that credit card transaction I'm doing, I use my Visa card. And what the retailer might do is it might go check to make sure that that's a good account. But actually, more importantly, a better example is this. I go into a department store and I'm going to buy some clothes, and the clerk says to me, if you take a new account from us, we will give you 10% off your purchase. They want me to get a credit card from them. So I say, sure, I'll get a credit card to get 10% off. So let me tell you how that works. They say, just give me one piece of identification. If you've got another credit card or some other piece of identification, we'll give you a new account right now to give you 10% off and then ship you the card. Well, here's how that works. That store mainframe will actually go talk to a credit bureau to check if you're creditworthy or not. That's usually a CICS talking to another CICS. And the credit bureau may come back and say, yeah, the credit rating of that person's pretty good, and they'll go ahead and do it. Okay? So that's where two CICS regions are talking using this component called the inter-system communication area. And if messages came out regarding that, it would be DFHCR, some unique number. So you got the idea. DFH is 3 characters, 2-character subcomponent, and there's many subcomponents to CICS is a very well architected transaction processor. Oh, that was a partial list. Here's the rest of it. So 2 lists of the subcomponents of CICS to let you know how rich CICS is as a transaction processor. Okay, on the screen here, going back to something simple, how it works, this represents a transaction name. So a transaction name it gets defined as a name, and let's say the transaction name is just ABCD. Well, if I'm at a terminal and I'm logged on to CICS and I type in ABCD, it actually goes into IMS System Services, because the IMS System Services is actually saying, oh, do I know about a transaction called ABCD? And it would say, yes, I do. And it actually would go to a program library. What's it doing going to the program library? The transaction, ABCD, the CICS definition knew that that's associated with a program called ABCD01. So the transaction would cause a program to be loaded into the message region area. Now this thing called BMS, this is a CICS component called Basic Mapping Support, and it's actually for configuring 3270 screens. And that's part of the application. Oh, right. Bruce pointed out to me, I'm going to go back a page. The ABCD is a transaction ID. What did I call it? Just a transaction name? Yeah. So it's technically a transaction ID. The transaction ID goes into System Services. There's a definition for that name, for that transaction ID. That transaction ID is associated with a program. The program comes off of a program library, probably a partition data set that's got the executable module in it. Executable module gets loaded, and then inside the executable module, I'm writing a 3270 screen. So then, oops, the 3270 screen is presented to me, and the user might input something that goes back to the program. Then the program might be interfacing with a file or a database to either inquire or update or insert some data. This file or database could be almost anything. DB2, IMS, a Unix file, a vSAM file, a data set, could be Oracle, many different other non-IBM products. So we'll talk about the application program interface. So inside, here's 6 languages you can use in CICS: COBOL, Java, C, C++. Actually, that would probably count as 2 languages, I guess. So it'd be a total of 7. Rex, Assembler, PL1. But in any one of these languages, you could say execute CICS. Well, what are the things you can do when you execute CICS? Here's all the different types of things you can do, and there's many. And there are verbs that you put after here as to what you want to do. Now, for example, execute CICS, and you use a BMS function. Well, BMS, basic mapping support, has different verbs like execute, CICS, send, map. And if you send the map, that's sending a 3270 screen to the terminal. Then you might execute CICS, receive map, and it receives from the 3270 terminal. But then we have other things like web services. You can say execute CICS web and be talking directly to a browser or any XML device or any HTML device. An example of that is you may have a terminal that talks to a credit card processing system, and then the credit card processing application can actually go after the application records that might be in vSAM, or you could have a web browser talking to the credit card application that goes after the same vSAM records. Now, one thing I'll mention here, this representation here is the 3270 screen, and this could be HTML or XML. And this came first, obviously, because 3270 has been around long before HTML was even drafted. And it's very interesting because there was one time I was explaining this to people, and I said, you know, this BMS is a specialty, and it's not difficult, but people get good with it. But probably more and more, we're going to see the execute CICS web used. And I happened to be somewhere where one person just kind of nodded their head on the ground and was kind of like I thought, oh, is something wrong? And the person said, well, I'm a BMS expert, and if that's going away, probably my job's going away. And I said, no, you don't understand. I said, if you're a BMS expert, let me tell you what's going on here. You know this. Younger people understand HTML and XML pretty well, and they know that. And there's going to be a need to convert this, the 3270, to this. The people that know this don't understand this, and they have a difficult time because they don't understand it. You know this. Now all you got to do is learn this, and you just doubled your value. Oh, they were really happy. Will the 3270 screen for CICS go away totally? No. I don't believe it ever will. You know why? It's faster. Speed is paramount in many large enterprises. Speed is paramount. Text is faster than images. Okay, this is a little bit more of an elaborate example where they're actually using a different piece of middleware that we're going to be having a session on to do store and forward of data called MQ series. Very powerful piece of middleware for configuring very innovative solutions. We'll have a session on that coming up. let me talk a little bit about CICS programming techniques. So here's a program. It's just, we'll call it PROG-V000, and there's logic inside of here. It can be any language. And one thing it does inside this program, it does an execute, kicks, send map. And when it does that, it writes the map to the screen, and it waits. It's waiting for the end user to hit enter on that screen with additional information, such as an account code, and then once they hit enter, it receives the map, and then it might read a file and update the file. A little bit of logic goes on. It sends another map back. It waits for the user to type in information and receive the map back, rewrite a file, send another map to do something. So all of this is in a single program in a single piece of logic. But when you send the map, it's waiting for the person to update the map for it to receive it and process. This programming technique is called conversational. So what some people do is they use a programming technique called pseudo-conversational. And how that works is they break up the program. So you might have a PROG-V00 that does some logic and it sends a map, but then what it does, it says, it tells CICS, inside the logic it says the return transaction ID is V001. So this program, I'm done with my job. Once they come back, invoke transaction ID V001. And so when the map comes back, because it kept track of it, it's like a unit of work with a number, and when it comes back it says, oh, I've got that map. Then it invokes transaction ID V001 that loads a new program. Program V001 that receives the map, does some logic, sends a new map out, and then does a return trans ID, say, oh, when they're done, invoke V002. So after they update the screen, transaction ID V002 comes in with the data, and program prog V002 might get loaded to receive the map, do some logic, and send the map. So notice there's no waits in here, and this is considered pseudo-conversational, so that you don't have larger programs taking up the virtual storage of the CICS transactional address space. Now, does this mean that everything should be written pseudo-conversational? Not necessarily. There are some things you may want conversational because you know that they're going to be doing it very fast, the entry is going to be very fast, and the wait time is very small, and maybe the programs are very small. Well, the programs are pretty small, the entry time is going to be very fast, and it needs to be critically fast. You might choose to make it conversational so that you don't have to load these programs, but the loads are pretty fast. But there are sometimes reasons that you might want to use conversational over pseudo-conversational. If you know if you potentially have long wait times, pseudo-conversational would be best. If you know it's a very large piece of logic, then pseudo-conversational might be best. Now, some of you might be involved in Java development, and there's a paradigm out there called J2EE. And when I first got exposed to J2EE, I was kind of confused. And the first thing that I was exposed to was they said, you've got to understand the MVC organization. And my first thought is, what is MVC? And it stands for Model-View-Controller. I didn't know what does Model-View-Controller mean? And so what Model-View-Controller really means is separating the business logic from the static content on a screen from the variable data. And so that's what J2EE is all about. you have static screen information, you've got the business logic, and you've got data separated from one another. Once I understood the product, once I understood the concept of MVC, I said, oh, CICS has been doing that for decades. The BMS is the static content on the screen. We have the business logic, the transaction ID program, which is the logic, and then we've got the data source. And there's a definition for the data source. There's a definition for the transaction ID associated with the program. There's a separate definition for the map. We separated the business logic from the static data that goes to a screen from the variable data. It's the same thing. In a way, conceptually, it's the same thing. So let's talk about starting CICS. I'm going to start CICS on the system, and something occurred to me on the system also, but I'll get to that in a minute. So I'm going to start CICS TS, probably on this system it's 42. And you'll see a bunch of messages coming out, DFH, and then look at this, see those subsystem, or the subcomponents, like SM, storage management, W2, Web 2.0 domain, SO, socket domain. You can write CICS applications with TCP/IP sockets. EJ, enterprise Java domain. DH, domain. I'm not sure what DH really stands for. But anyway, you got the idea. SI, initialization. XS is internal security. So let's see what I got on the next screen here. Once I start CICS, if I go to SDSF, there is one address space for CICS, and it is indeed a started task, STC, and it would be an execution. It's a started task, address space running. Now, if I put a question mark to the left of CICS, it's going to give me the different DD names for that started task. Well, this particular DD name, MSGUSR, it is the log of DB2 activity. But earlier, I told you there's a system log. Well, the system log logs information where the services of the operating system are used. But there's a great deal of activity going on within the CICS area that the system doesn't log. But CICS activity that's unique to CICS, CICS has its own log of information, and it's being written to a DD name called MSGUSR. So if you want to find out what's going on inside of CICS, one of the best places to look is here, MSGUSR DD name. This is an architectural thing, and I do this with CICS because this is not unlike large enterprises. What I want to point out is notice the CICS is here. Lots of CICSs, lots of CICS regions. But then what I did, under CICS, I call this a TOR, I call that an AOR, I call this an FOR. Well, what many people do, large enterprises don't run just one CICS or just two of them. Sometimes they run hundreds of them. And then what they do, they get really clever. They'll take a CICS and say, this CICS is a terminal owning region. I'm going to handle the terminal traffic. And then when a transaction comes in, that transaction is going to go to the application owning region. The application owning region is where the program will get loaded for processing. But then, if I need data, the CICS application owning region might talk to a CICS file owning region. This CICS file owning region's got a bunch of, say, VSAM data sets attached to it. a CICS application owning region could potentially talk to an IMS-DB. A CICS application could potentially talk to a DB2. Well, inside these CICS application owning regions, you could have many different types of applications. Some might be merchandising, some may be credit, or whatever. Now, so I'm showing a mix of middleware in here. The other thing I'm showing up here that we'll talk about on Thursday is the communication server can talk to anything out there in the network. HTML, XML, 3270, point of sale devices, other mainframes, automatic teller machines. We'll talk about that. So talk to anything, any intelligent device. But then this communication server can also talk to WebSphere application server. It can also talk to something called MQ series, and we'll talk about that a little bit later today. But I want you to know something could come in CICS and it says go over to WAS, WebSphere application server, to do something. Or it could come in to WebSphere application server and say, I want to invoke a CICS transaction. And actually it may go down to here. This interconnectivity is very possible, and many people do things like this. Why might they have 2 or 3 of them? Redundancy, different machines. But you can architect application solutions for an enterprise using the zIOS environment with all the different middleware. These are how large enterprises run, and this picture is actually a rather simple picture compared to what large enterprises can actually do to be super industrial strength and be very fast servicing the whole internet and stores. Yeah, question?
Where does the CICS transaction gateway fit in this platform?
Good question. The CICS, there's another component called the CICS transaction gateway. And it actually ends up being, it runs inside of Unix System Services now, if I'm not mistaken. Is that correct, Bruce? It's actually a Unix services application? Not all of them. It can, or it can be, it actually sitting inside of zIOS. Think of it as an adapter, in a way, to talk to the communication server.
So it would fit between like the COR and the Cont?
Yes. In fact, it may be, there's a thing called a CTG, CICS Transaction Gateway, to actually add more flexibility for talking to things.
For CICS and WAS to communicate between the CTG.
And Bruce, who was in the room, pointed out one place that the CICS Transaction Gateway is used is when WAS is talking to WebSphere Application Server, is talking to CICS, it would very commonly use something called the CICS Transaction Gateway. Do you have to use the CICS Transaction Gateway? Because I suspect you don't absolutely have to if you do a little bit more programming.
You don't have to. They have different.
Right. So in WebSphere Application Server, which is a Java app, it would be possible to talk directly to CICS, but the CTG is another little middleware piece to make the programming have to do less or think about less. So think of it as like a super adapter.
Point to CICS FOR area. Yeah.
So Bruce is telling me to point to the CICS FOR area.
That stands for file owning region.
Yes, and Bruce pointed out that stands for CICS file owning region.
And there are regions that has a special purpose. For example, there is like PSOR, temporary storage, owning region.
Right, and so Bruce is pointing out to me that there's also types of regions called temporary storage regions. So FOR, file owning region, AOR, application owning region, TOR, terminal owning region, is one example of the different separating the functionality from the CICSs. Could I do all of that in one CICS region? Yes. Do I have to? No. So sometimes people separate out for speed. But Bruce is pointing out to me that there's sometimes people actually do not only terminal owning regions and application owning regions and file owning regions, but temporary storage, type of temporary storage regions, and I won't get into what temporary storage is right now. There's a thing you can do inside of applications to use temporary storage. By the way, I'll go ahead and mention this now. This zIOS introduction in workshop, I want you to know that many of the disciplines I talk about during the 5 days, we could take any one of these, like CICS. I could spend 2 weeks on CICS alone. I could spend a full week on administration and another full week on application development, easily. Easily. So I'm trying to give you a highlight of what's going on here. So inside of CICS administration, the programs and the programs get launched by something called a transaction ID. And the maps that get delivered are also require a definition. So for CICS to understand the transaction ID, you've got to define it. There's something referred to as the CICS system definition, CSD, and inside of there is where you put the definitions of you give it the transaction IDs, and in there you associate it with a program name, and you might say what language it is. And so this CSD is where you define things, because different applications may have different transaction IDs and different program names. I'm not going to say a whole lot more there. I will point out this though. Earlier I mentioned a terminal owning region. Actually, they do the presentation there. Application owning region, business logic. I mentioned that one was an FOR, file owning region. Some people might refer to something as a DOR, a CICS DOR, data owning region. So it's whatever nomenclature you want to use, and that's CICS regions for data access, maybe going to vSAM files, a relational database, even a hierarchical database. So I'm going to start up CICS in a minute, and when I do, each one of you can log on. The way you're going to log on, I'm going to have you bring up the 3270 screen that you used for TSO, and I'm just going to have you type in CICS. If you did that right now, it won't come up because I haven't started CICS. Once I start CICS, on our system, I didn't put in any security. I could go into the system. I could go into the system parameter area for the CICS parameters. I can say turn security on. Here's what I want to protect. And it's not all that difficult. But if you don't turn security on, you get a screen that looks like this. And CICS 3270 screen works different than ISPF. You actually clear the screen to enter a transaction ID. And if ever you get on a CICS and see this, there's no security. You require no authentication to get to it. You're there. You can do anything that's available inside that CICS when I say anything. But then you clear the screen, and here's what I'm going to have you do. I'm going to have you type in a CICS supplied transaction. This CICS supplied transaction, CEMT, is the common operator transaction. Let me talk about CICS supplied transactions for a moment. When you install CICS, it automatically comes with a bunch of transaction IDs that are associated with a bunch of CICS supplied programs so that you can do various things within CICS. All CICS transaction IDs begin with C. So if ever you start reading the application development book or the administration books, they will recommend that you don't start your business application transaction IDs with C, because it might conflict with a CICS supplied transaction. So for example, the first credit application you write, which I did one time, I actually started using C for credit. Well, I immediately ran into problems with conflicts on using